Hello everyone. So today we'll start another subject, that is fluid mechanics. Okay. So fluid mechanics subject we're going to start today. So from the fluid mechanics first chapter, that is fluid properties. So we'll be discussing some MCQs from the first chapter of fluid mechanics, that is fluid properties. So it will be beneficial for both mechanical and civil students. So as this is a combined subject of for both the branches, so both of the students can be benefited from this lecture. So okay, so without wasting time, let us move forward. So first question is, mass density of the liquid is given by what? So we know that is rho is equal to, that is mass per volume. So here we can see the option A will be the correct one. So let me check. Okay, so this is the option A is the correct one. Then next one, the bulk modulus of elasticity. Okay, so what is the relation in between bulk modulus of elasticity and your pressure? It is asking about. Okay, so for K isothermal, okay, so it is directly related with pressure, and for K adiabatic, that is K adiabatic, that will be related with gamma into P. Okay, so it is you can say directly related with pressure, that is increase with pressure. You can say B will be the correct option here. So here B option is the correct one. Then moving next, the rise or fall, that is rise or fall of head H in capillary tube of diameter D and liquid surface tension, that is sigma, and specific weight W is equal to what? So we know that is H is equal to what? 4 sigma cos theta divided by rho d, that is specific weight, into t, that is omega d. So or wd, whatever you can say. So if cos theta will be equal to 0 degree, then it will becoming 1. So you can say that will be equal to 4 sigma by wd. Okay, so here A option will be the correct one. Then moving next, as per the law of fluid friction for steady streamline, so according to steady streamline, okay, so this is the B option here. Okay, according to friction, okay, law of fluid friction for steady streamline, it is varies in the inverse proportion to pressure. No, so it doesn't depend on pressure, actually it is depending on the viscosity, okay, or velocity you can say. So but it doesn't depend on your what pressure. So C option will be the correct here. Then moving next, so C option will be the correct one. Then moving next, in the fifth number question, an ideal flow of any fluid must satisfy which law or which equation? Okay, so for ideal flow condition, your continuity equation of the fluid, that must be satisfied. Okay, so where continuity equation is your what? Rho A B will be equal to constant. Okay, so this equation must be satisfied if you can say compressible or incompressible, according to this equation can be satisfied. So here D will be the correct one. Okay, then moving next, uh, 6 number question, it is flow which neglects change in the transport direction, that is known as which type of flow? Okay, so if there will be a single direction flow and there will be no force flow in the transport direction, then that will be obviously called as your A, that is one dimensional flow. Okay, so A will be the correct answer here. Then moving next, seventh number question, the property of a fluid which enables it to uh, resistance tensile stress is known as your what? So the tensile strength resistance, it will be known as your cohesion. Okay, so option C will be the correct answer here. So cohesion is the resistance tensile stress. Okay, then question number 8, kinematic viscosity is equal to, kinematic viscosity is represented by nu, that will be equal to dynamic viscosity, that is mu divided by rho. So we can say dynamic viscosity divided by density. So option A will be the correct answer here. So option A. Then moving next, which one of the following is the bulk modulus, that is K of the fluid? Okay, so we know that is bulk modulus is equal to minus dp dv by v. Okay, so to this equation also we can write like this: K is equal to dp divided by d rho by rho. Okay, so we can change this volume into density term. Okay, so this rho can be taken into the numerator, so I can write rho dp divided by d rho. So I can find this option in D, so this will be the answer, rho dp divided by rho. Okay, then question number 10, hydroplastic substances are non-Newtonian fluid for which what is happening? Okay, so for hydroplastic substances, the what is the how it can varies, or how flow is occurring. So stress is equal to here mu du by dy raised to the power n, where n is less than 1. Okay, so if n is less than 1, then what will happen? So dynamic viscosity increases with time, for which shear stress applied, or dynamic stress increases at the rate of shear increases, dynamic viscosity increases at the time of which shear flows applied, or fourth option is dynamic viscosity decreases at the rate of shear increases. So here is the option number D will be the correct one. Dynamic viscosity decreases as the rate of shear increases. Here n is less than 1. Keep remember this one. Okay, then moving next, an ideal fluid has what? Okay, so actually what happens, our ideal fluid doesn't exist, so this is an imaginary concept. So what are the different assumptions for your ideal fluid? So for getting an ideal fluid, so it should be incompressible and non-viscous. Okay, so it should not be viscous, matlab we can say it is should be a inviscid flow, inviscid flow. Okay, and it should be incompressible. So option number D will be the correct one here. Then moving next, Pascal second is the unit of what? Okay, so Pascal second is the unit of your kinematic viscosity. So we can find out this one. So we know tau is equal to what? Tau is equal to dynamic viscosity mu into rate of shear strain, or velocity gradient, you can say du by dy. So if we take this term into this side, and unit of this is Newton per meter square into dy, that is meter, divided by du, that is meter per second. Okay, so meter can be cancelled, so I can get here Newton per meter square into second will be go up, so that will be Newton divided by meter square per Newton per meter square into s. So Newton per meter square can be written as Pascal, and that will be multiplied with s. So we can get the unit of kinematic viscosity is Pascal into second. So C option, sorry, kinematic, so this is not dynamic viscosity. So Pascal second is the unit of dynamic viscosity. Okay, then moving next, when a fluid is in motion, the pressure at a point is same in all direction. Okay, so then the fluid is told as your what. So if we are taking that our pressure should be small, or that is pressure at a point in is same actually in all direction, then we can say this will be an ideal fluid. Okay, so in case of your ideal fluid, your pressure at a single point, it will be same in all directions, so it will be the ideal fluid. Okay, so C option will be correct. Then moving next, 40th number question. Mercury doesn't wet the glass surface. This property of mercury is due to what? So in case of your any fluid that or anything, any substance, we are having cohesion properties and adhesion property. So due to adhesion means the intermolecular force, that is extramolecular force, we can say, means the force in between two opposite molecules or two different molecules, you can say. So the adhesion force for your water is okay, high, and in case of your mercury it is very less. Okay, likewise cohesion is what? It is the intermolecular force, the force between the but particles of same molecule. Okay, so that is known as your cohesion. So mercury doesn't wet means it cannot spread over the glass surface, so it is the property, it is due to its cohesion property, you can say. So option B will be the correct answer here. So next question is the 15th number question. So it is given the velocity distribution for flow over a flat plate is given by this relation. So u is equal to y minus y square, where u is given in meter per second at a distance y meter above the plate. Okay, so at a distance y, what is the condition of your u? That is equal to in the function of what? Y minus y square. Okay, so what is the shear stress value? So we need to calculate tau here, tau. Okay, where at y equal to 0.15, so we need to calculate tau y. So here dynamic viscosity of the fluid is given 8 volts. Okay, so let us start it. So here we need to calculate tau y. Okay, that will be equal to what? Mu into du by dy. Okay, and at where y equal to 0.15. Okay, so here it is given mu, that is 8 poise. So we need to convert that into SI unit. That will be equal to 8 into 10 to the power minus 1 into du by dy, where u equal to y by y minus y square. So differentiation of y minus y square, I can get to y 1 minus 2y. So this value at y equal to 0.15 we can calculate. So I can write 0.8 into 1 minus 0.3. Okay, so if we will be putting the value, that is y equal to 0.15, then we can get this value. So that will be equal to 0.8 into 0.7. So multiplication of this, it will be giving you 0.56. Okay, so option C will be right here. So 0.56 Newton per meter square will be the answer here. Okay, then moving next, a hydrometer is used to determine what? So a hydrometer is basically used to determine the specific gravity of the liquids, or we can say relative density of the liquids. So option C will be the correct answer here. Okay, next question is 17th number question. So here pressure intensity inside the water droplet is, okay, so we know that is P equal to 4 sigma by D. Okay, where sigma is the surface tension and C is the, so it is the D, it is D and this is sigma here. So sigma is the surface tension and D is the diameter of the bubble. Okay, so C option will be the correct answer here. Then moving next, one stroke equal to what? So one stroke, this is the sorry, it is the unit of what? Kinetic viscosity. Okay, so nu so that will be equal to 1 centimeter square per second. So A option will be the correct answer here. Then moving next, dimension of surface tension is what? Okay, so we know the surface tension equal to force per unit length. So unit sorry, force unit is in Newton and length unit is meter. So Newton can be written as kg meter per second square. Then it will be multiplied by meter in the denominator. So meter can be cancelled. So I can get that is kg per second square. Sorry. So kg per second square I can write m1 l0 t minus 2. So here C which option B is the correct answer here, m1 l0 t minus 2. Okay, then moving next, to prevent oscillation of the meniscus of length of connecting tubes should be what? Okay, so what we are doing, if we are putting any capillary tube, what will happen inside any beaker or where some liquid will be there. Okay, so it will be rising, your liquid will be rising inside that capillary tube. Likewise it will be connecting a tube, or okay, so if will be connecting with a small tube, okay, then there will be we can provide the oscillation in the meniscus. Okay, so C option will be the correct answer here. So for 20 number, C option will be correct. So if we'll be connecting a small length tube or small length connecting tube, then oscillation can be prevented of the meniscus. Okay, then 20, the expression of capillary rise that we have already known, that is B option will be correct. So 4 sigma cos theta by rho g d. Okay, so previously what I mentioned, that is uh, W, that is the specific weight. So specific weight will be equal to rho, that is density of the liquid, into G, that is the acceleration due to gravity. So W equal to rho G. So we can replace here W by rho G. So we can get 4 sigma cos theta divided by rho G D. Okay, then so this will be the answer. Then the torque in Newton meter is required to give 3 meter cube per second of water. Okay, a momentum. Okay, so that it has a tangential velocity, it is given 3 meter per second, and distance of that is 1.8 from the axis. Okay, so and we need to calculate the torque in Newton meter. Okay, so for calculating torque I can write, so what are the given data here? So Q is given 3 meter cube per second, and the velocity is given, that is equal to 3 meter per second, and distance is given r or l, you can write. So that will be equal to 1.8 meter per second. Okay, and we need to calculate the torque here. So torque equal formula, that is rho q b into r. Okay, so everything is given here, directly we can put in the formula and calculate the answer. So rho, rho for water is, that is 1000 into q is given 3, and velocity is also given 3, and it will be multiplied with r, that is 1.8. so if you can calculate this value, then you can get that will be A. Okay, 16200. So A will be the correct answer here. Then moving next, 1 poise is equivalent to what? So 1 poise, it is an CGS it is a CGS unit for your dynamic viscosity, so that will be equal to 1 gram centimeter per second. Okay, so that will be the answer, correct answer here. So B option will be the correct answer here. Then moving next, the rate of change of momentum represents what? Torque. Okay, so rate of change of momentum represents force, but the rate of change of momentum is given by torque of the applied fluid. So C option will be correct here. Then hydrometer is used to determine what? So already I think we have discussed, that is the specific gravity of the liquid. Okay, so hydrometer is basically used to calculate the specific gravity of liquid, or relative density you can say. So D option will be correct here. Then moving next, the shear strain relation, okay, of the Newtonian fluid is a, okay, shear strain stress strain relation, okay, stress strain relation is of the Newtonian fluid is given by, okay, which type of relation it is. So we know that is shear stress, that tau is equal to mu du by dy. Okay, so it is the velocity gradient. Here we can represent this equal to mu into d theta by dy, rate of shear strain. Okay, so there is a linear relationship in between your shear stress and strain. So option A will be the correct one here. Then moving next, Newton's law of viscosity is a relationship between, already now I told you, so B option will be correct, shear stress and rate of shear strain. Okay, so B option will be correct. Okay, so with this we reached at the end of the lecture. So thank you for watching.